In this video, I would like to discuss about different types of adsorption isotherms. In the previous lecture, we has been discussed about the Langmuir's adsorption isotherm and BET adsorption isotherm. So what is the adsorption isotherm? Adsorption isotherm is the empirical relation between the amount of the substance adsorbed per unit mass of the adsorbent with equilibrium pressure at constant temperature. So on the basis of the adsorption isotherm, we can understand the relationship between the amount of the substance adsorbed per unit mass of the adsorbent against equilibrium pressure. So adsorption isotherm, it is a simple graphical curve which gives the relation between the amount of the gas adsorbed per unit mass of the adsorbent against the equilibrium pressure. So there are 5 types of adsorption isotherms. So let us see these 5 types of adsorption isotherms. So this is first one. So in this adsorption isotherm, you can see here X upon M, it is the amount of the substance adsorbed per unit mass of the adsorbent, where X it is amount of the substance, adsorbed, and M it is the mass of the adsorbent, For example, if we take charcoal as an and nitrogen gas as a adsorbate, then whatever be the mass of the charcoal, that is the value of the M, and whatever be the amount of the nitrogen gas adsorbed, that is X. So on this y-axis, we have to take the amount of the substance adsorbed per unit mass of the adsorbent with pressure, against pressure. So this is the nature of the graph obtained. This is type first. Now this type of the graph belongs to Langmuir's adsorption isotherm. And we know that Langmuir's isotherm, it is the chemical adsorption process, chemisorption or chemical adsorption process. And we know that in Langmuir's isotherm, there is a formation of unilayer on the surface of the adsorbent. There is a formation of unilayer, only one layer, it is formed on the surface of the adsorbent. So it is a monolayer formation process. So this graph shows that as the pressure is increases, okay, the amount of the gas adsorbed per unit mass of the adsorbent, it is increases. But after some time, it is remains constant. Once the full surface area is covered by the gaseous molecule, and once there is a formation of the unilayer, then beyond that the amount of the gas cannot be adsorbed. Okay, so it accounts for the effect of pressure on the adsorption of gas molecules on the surface of the adsorbent. As we apply the pressure here onto the gaseous molecule, there is a formation of unilayer on the surface of the adsorbent. Up to the formation of the unilayer, the amount goes on increasing. Once all the sides of the adsorbent being acquired by the gaseous molecule, then there is no further adsorption. So later on, the amount remains constant, and the saturation will be takes place at this point P0. So in this case, P0 it is the saturated pressure. P0 it is the saturated pressure. So you can see here the adsorption of gas molecules increases. Okay, adsorption of gas molecules increases with increase in pressure till a saturation stage is reached. So this is the saturation stage, and at this saturation stage, uh, the surface of the adsorbent is fully covered. Okay, it is fully covered. Beyond that, the gaseous molecules cannot be adsorbed, or no surface is available for the adsorption process. Okay, so surface of the adsorbent, it is fully covered with a single layer of gas molecules. For example, adsorption of nitrogen gas on charcoal at 78 Kelvin. So this is the type first adsorption isotherm, which explain Langmuir's adsorption isotherm, that is monolayer formation, monolayer physical adsorption. So this is the type first adsorption isotherm. Let us see now type second. Now here variation is somewhat different. Okay, once again this is the graph of x upon m versus pressure. So you can see here in the type second adsorption isotherm, this isotherm is observed in multi-layer physical adsorption process. Multi-layer physical adsorption process. It means whenever the number of layers are more and more. For example, see here, this is the surface of the adsorbent, and such layers are formed there on the surface of the adsorbent. This is first layer, then second layer like this. So in this way, the number of the layers are going to be repeat onto the surface of the adsorbent. So there is a formation of the multi-layer. So it is a multi-layered physical adsorption process. The point Q represents the transition point where the formation of unilayer is complete. At this point, the unilayer is complete there, means one layer. Now we know that in multi-layer adsorption process, first of all, unilayer is formed, then onto that unilayer, second layer is formed, then third layer is formed. So in this way, it is going on. Multi-layer formation process is there. So this point, it is the Q is the point where there is a formation of the monolayer or unilayer. Beyond that, number of layers are going to be forming, and the amount of the gas adsorbed per unit mass of the adsorbent will be increases as the pressure will be increases. Okay. So the example of this adsorption of nitrogen gas on silica gel, that is the example of this type second. Adsorption of nitrogen gas on silica gel. It is belongs to the type second. So in this graph, first of all, there is a formation of the unilayer. And once the unilayer is formed, later on also the process is continuous. As we are increasing the pressure, the amount is also going to be increasing. And when there is a complete formation of the multi-layer, then this saturation stage will be occurs here. So in this case, amount of the gas adsorbed or amount of the substance adsorbed, it is higher as compared to the type 1 adsorption isotherm. Because in type 1 adsorption isotherm, there is only one layer is formed. So now let us see the third type of the adsorption isotherm. Okay, type third. This isotherm represents the multi-layered physical adsorption process over a porous adsorbent even before the formation of the monolayer is complete. Okay, even though monolayer formation is not complete, but multi-layer formation is already started. Hence, in this case, you can see here the amount of the gas adsorbed per unit mass of the adsorbent, it is going to be increasing very fast. Increasing here. Okay, and at this point, the saturation stage will be reached here. So, this isotherm is observed in case of the multi-layered physical adsorption process, even before the formation of the monolayer. In the type second adsorption isotherm, first of all, monolayer is formed, then multi-layer is going to form. But in this case, before the formation of the multilayer, monolayer, even though multilayers are formed. So such type of the isotherm lacks in transition point. There is a no transition point here. In the previous isotherm, there is a transition point, this point Q. Okay. After this point Q, multilayer process has been there. So such type of the isotherm, there is a no transition point. Example, adsorption of bromine vapor on silica gel. It is the example of the type 3. Now let us see the type 4 adsorption isotherm. The variation is now different here. It is going to be increasing later on, some increase there, again fast increase there, remains constant. The same x upon m versus p. The above isotherm represents a saturation in the case of multilayered region of the adsorbent at high pressure. At the high pressure here, the saturation stage will be accompanied by a capillary condensation. It is one of the type of the physical adsorptions occurring on porous material. So example, it is adsorption of benzene on ferric oxide gel. So these are the different kinds of the adsorbent: ferric oxide gel, silica gel, nickel. Okay. So benzene, it is adsorbed onto the ferric oxide gel. So you can see here the different type of the variation is here. Okay. So due to the capillary condensation, type 4th, and now the last type 5th. Okay. So you can see here, once again here started from this, going to be increasing. So this isotherm represent the case of formation of multimolecular layer relatively at low pressure. Even though pressure is low here, but adsorption it is going to be increasing, and at high pressure. Okay, a saturated point is reached. This is the saturated point at high pressure. So the example of this type of the adsorption isotherm, it is adsorption of water vapor on charcoal. Adsorption of water vapor on charcoal. So thus in this video, we has been discussed the different kinds of the adsorption isotherm. So type 1 and type 2 adsorption isotherms are very important one. Type 1, it is purely belongs to the Langmuir's adsorption isotherm, because there is only formation of unilayer, monolayer onto the surface of the adsorbent. But type 2, it is belongs to the BET adsorption isotherm. Browner, Emmett and Taylor has given such type of the adsorption isotherm. First of all, there is a formation of the unilayer and monolayer. Again, if we increase the pressure, the amount of the gas adsorbed per unit mass of the adsorbent, it is going on increasing. So this graph shows increasing amount. Okay, it is going to be increasing here. Okay, so Q is the transition point here, and BET adsorption isotherm, it is belongs to this. So this is about the various types of adsorption isotherm. So what is the adsorption isotherm? Adsorption isotherm, it is the graphical curve which represents the relationship between the amount of the gas adsorbed per unit mass of the adsorbent with pressure. Because there is a very interesting relationship between the amount of the gas adsorbed per unit mass of the adsorbent with equilibrium pressure. As we know, if we apply the pressure onto the gaseous molecule, the amount of the gas adsorbed will be goes on increasing. Okay, so in the type 2, first of all, there is a formation of unilayer. Then if we increase the pressure, the multilayer formation will be takes place there. Okay, so this is about the various kinds of adsorption isotherms. Various kinds of adsorption isotherms.